right, okay. Hello, everyone. This is Pankaj Deshpande. I'll just share the slides that I have and just get started. Okay, so I'm Pankaj Deshpande, architect FlashSystem, and been with IBM for greater than 15 years now, around 15 years, and it's a great opportunity to connecting with all of you. What are the key transformation that we are investing in, we have invested in the flash system grid, and especially around mobility, there has been a lot of interest. So today's session, I'm focusing more on the mobility part of it. It's 30 minutes, so if there are any questions, and if there is a lot of material for me to cover, hopefully we still have a few minutes, but if not, then in the end, then do send the queries that you have, and then we'll take it on from there. So without spending more time, let me just get started. So this is the agenda for today. I'm going to talk a bit about what the flash system grid is, trying to connect everyone with the grid vision, what is the grid architecture, and then we'll talk a bit about how do we construct the grid, but largely we'll spend time on non-disruptive mobility and what is the fabric of mobility that we have as a part of this architecture. We'll try and cover some of the key use cases, so we'll not be able to go through the value proposition of all the aspects of the grid, but we'll just focus on the mobility, which in itself is the key one. So the flash system grid is a platform which is comprising of the multiple systems controllers, and there is federated storage, and there is a federated management, and it has got a fabric for mobility, is how I put it. Essentially, you have multiple systems in the grid which are acting like one. In the 90s, we used to have this, drives, and we used to manage individual drives, and with the RAID, the RAID arrived, and then with no more managing the drives in a similar way. Flash system grid is trying to get multiple controllers together, have these loosely coupled set of systems, and have them managed centrally, governed by a common management system, having the common governing policies, rules, and a lot of automation, accelerated decision, and also you get a scalable infrastructure in terms of the capacity, performance, different tiers of the storage, all managed as one. So this has got this is how your grid would look like. There would be, there are two layers. There are controllers, the physical one, and then you have those blue boxes, which Chris in the last call has introduced, the storage partition. I'm going to spend some time on that one, but it's really, this is how your grid would be looking like, having the physical system and then also the storage partitions in it. And there are a number of operations that could be simultaneously going on at that point. Some migration, some systems in HA, some doing replication, some in three-site, some maybe just having the basic partitions. The grid, I think there is some inspirations for the grid, and it really was thought of as an architecture which will try and meet the demand of the modern IT in terms of the scalability. Maybe can we have the agility, the usability, the mobility, in general, a flexible environment, and then essentially trying to get an efficiency and utilization through the IT optimization, and reduce the cost of management, the skills required to manage it on the other side of it. So all this good stuff that we would want in the modern IT. So this is a modernization journey of IBM FlashSystem through the grid. FlashSystem grid architecture. This gives me an opportunity to sort of present the grid architecture. At the lowermost layer, you have a physical storage where you have the performance and capacity scaling that's happening and so you can go on adding the flash systems. Up to 32 systems you can add in a single grid today. And then on the top of that, you have the virtual storage layer, which is your storage partitions. I'll just step ahead, and this is a picture I like to use. And in many ways, the world of VMware was, it was transformed where, VMware transformed the compute side with the VM as basically the, workload, started sitting in the virtual machine, and the virtual machine itself had loads of features in terms of the vMotion and the resiliency and the high availability and all those aspects, right? No non-disruption constructs were built around the virtual machine. In many ways, what VM is to the workload world, the storage partition is to the workload storage world of flash system. So you can almost, it is not a VM, but you can look at it like a container, which is having everything that the workload needs, or a set of workload needs. You can construct it in different ways and pack it all in this storage partition. And then you have this, then there is a freedom from the physical layer, and this virtual object itself can, using the mobility fabric that we have designed as a part of flash system grid, it's able to travel seamlessly, non-disruptively within the grid. And so this becomes a foundation for a lot of conversation, a lot of good ideas that we're going to talk about. So that's your virtual storage layer. And then on the layer up is that the federated storage management. That's where you have you still have this idea of, can we have a single config domain that we can create? Can we learn from the cloud and add a lot of stuff that we learned in the cloud in terms of cloud user experience? Can we add it here? Can we have a lot of automation that makes it easier? So the grid management layer in terms of, and also the AI insight, a lot of AI insights that we would be actually, we will be brewing it in Storage Insight, which is your top layer, that actually will be made available to the user, to the admin, through the grid management, single pane of glass. So that becomes a single pane where you're managing multiple systems in the grid and also the multiple partitions in the grid. So that is the four-layered architecture. We covered this. And, I think we have covered this point, and Chris has also covered, but I just want to, once again, just summarize it in a minute, maybe, because all the mobility conversation that we're going to have today is around storage partition. So, I'm just summarizing it again. Storage partition is encapsulating, all the stuff that the workload, in terms of its interaction with the storage needs, in terms of, the storage needs to know which of the hosts that are going to talk to it. It will have a volume groups, volumes, there are associated policies of HA, DR, and the data itself. All of that put together is, then there is this new unit of management partition. And then you can visualize it as a workload storage, or if you take multiple workload put together, you can visualize it as a virtual controller. And so that becomes the unit of management from here on. Now, some of the subsequent slides Chris has covered in last conversation in detail. So I'm not going to go into that. He has spoken about the PBHA. He has spoken about async DR, and then he has also spoken about the three sites. So I'm going to go to the next thing. Is that just time check? Okay. So I'm going to look at now, how do we create and manage the flash system grid? So now this is an important slide, which is kind of showing that the grid, in the grid, you have a flexibility in terms of what kind of hardware you can mix. So you can really have, all kinds of families of the hardware that you can mix, the C200s, the 5K, 7K, 9K, those series. And one system, which one IO group or one dual controller becomes a unit of scale. You can add 32 flash systems in it from 910, and it employs a cluster, loose clustering between the systems, and within the system, across the system is kind of loosely clustered with these 32 flash systems. And then within the dual controller, it has to be a tight clustering, like a traditional clustering. It scales your performance, linearly, the capacity linearly. But one of the major sort of advantage is there is no, with your different systems could be at the different level of the software. So your update domain, your failure domains, then they all can be separate. So it's not required that the grid has to be of one level of software, for it to function. So that that also sort of gives an opportunity that rather than big bang storage refreshes, maybe there is an opportunity that grid allows of incremental modernization. I mean, essentially, you don't need to make a big bang, refreshes. Maybe you could potentially do it incrementally because you can mix and match as you move on. So that is that. There are two aspects of the grid in terms of the grid management. Traffic is all IP based, and the grid data traffic uses the partnership as a construct. Need to have, in terms of the grid management traffic, all systems need to see each other, and from a grid data traffic standpoint, the creation of the partnership itself is on the need basis. If you're getting the systems in HA or DR, or you try and do the migration, then at that point in time, you would need the partnerships to be created. Now, for migration, some of those aspects, even of partnership creation, is also automated. It's all secured using the communication certificates, and the grid management communication itself happens using the REST traffic. So this is trying to show that, okay, how can I create a flash system grid if you have a system that is at a level wherein the flash system grid is supported, which is, it's going to give you an option. It's going to tell you that there is going to be a notification which you can discover it there, and you can create a new flash system. It's easy. Once you create that you're going to get on the right-hand side, there is a single sort of a dashboard where you would have two views. So you have this view of the storage systems in the grid and the storage partitions in the grid. And then you would have the visualization of the physical capacity, the logical capacity, what's going on in terms of the systems. Are there unreachable systems there? Are there anything that is drawing attention? So the admin can come to this particular place, this dashboard, and from there can maneuver which is part of its infrastructure that needs attention. And so we call the system, which is the first system, we call it a grid coordinator. And then it can onboard the number of member systems into the grid up to 31 more, which is like total 32. Now, once you've configured the member, then from all the members, you can actually do the grid visualization and management. So you can get using the user credentials of that particular system, you could you could get into the grid and you'll land into the dashboard that we just saw, and then from there you can go through and do the single pane of glass management that I was talking about. But the grid construction itself is restricted to the coordinator system. Again, adding the additional members is easy. You can just go exchange the trust. Once you establish trust between the two systems, there is a simple join and accept and approve flow. And once you do that, then the systems will get added to the grid. And this is what I was talking about. This is the storage system view where you can see all the storage systems. You click on that link, it's going to take you, it'll pop up the system itself. So there's a seamless navigation experience which has been attempted as you go across the grid and come back into the grid. So you go to the system, look at what is happening there, come back. And so that is being attempted to do as much seamlessly as possible. So it does support SSO. And if there is no SSO, then you may have to provide the explicit login there, and then there are some interesting features that you can look forward to in the time to come. So that's about the storage system view, and then equally all the partitions in your in your grid. This is the one place to go to. You can visualize your if you have multiple sites, you have a HADR relationship of that partition across multiple systems in the grid. It's going to allow you to visualize these HS status, DR status, or if there are any migrations going on, then it's going to is going to show you that on that dashboard. And then when you click on that particular link, it'll allow you to go and do the partition related operation there. Now we come to the interesting part of the non-disruptive migration. There are a number of use cases, but I'm going to cover them right in the end, in detail in terms of what is the what are the drivers. But the key thing I wanted to put here is that there are a number of challenges involved in the storage migration. Talking to a lot of customers, the large enterprises, banks, service providers, they all need a huge amount of workforce, just to manage migration. So I was talking to some of the bank, they were having about 50 to 100 staff just to manage the migration, about 60 maybe. Another bank I was talking to said 34. So there's a big, staff that is required just to because one or the other thing is happening. Either there's new storage is being onboarded, or some storage is retiring. There are refreshes that are going on. There are maintenance cycles, etc. So we'll talk about that. And then, of course, the answer to some of these challenges, the storage partition migration technology does provide that, supporting all of these various use cases, which we're going to see in the subsequent charts. I'm just going a little bit fast because I just want to make sure you get to see all the important stuff. So migration process itself, when we initiate the migration from the grid, you can do that from the storage partition view. But when you do that, you get sort of, when you initiate it, gives you a plan. So on the right-hand side, you have that plan. And then but those are not the number of interventions that the user really needs to go through. This is just the process. A lot of stuff that happens is under the hood. There are some aspects that we need to set up ahead, and then there are aspects that are automated. So there's another slide where we're going to cover what do I need to set up ahead. But I think the key point is that the uh, the metadata movement, the object movement, the policies, everything that we saw, inside the storage partition, in terms of its configuration, as well as the host-facing configuration, application-facing configuration, as well as the data itself, is all happening automated. In certain environments, the host side also, we have developed a technology which can automate it, either relying on the native support or some other technology we have developed as an automation technology. And so what are the aspects that require user intervention? Only two at the most. Rescan is not required. That intervention won't be there if you have an environment like VMware, IBM I, which can do automated rescan, or it is not required if you have set it up one time. Then that intervention is not there. So you start, and then I think it's the only one point where it migration commit point where it asks you that are you happy with the, so you can look at the performance and decide to commit the migration. So that's the only intervention point, and we're going to talk about what happens. Once you commit, of course, the source copy would go away, and so therefore that's an opportunity given for the user. There any problem that is going to show up as an error. This is the, this is the core of the non-disruptive migration. It really builds on the top of the HA technology that we have. And I think there was a question last time to Chris as well. Can we not use the HA itself? Yes, and that's exactly how we have built it. That the HA technology, the partnership technology, these these aspects we have kind of utilizing this, and we have created a migration core on the top of it, and a lot of automation that user doesn't need to do. A lot of manual error-prone actions, and it's assisted by AI Insight from SI. Supports all kinds of host and all kinds of interconnects, and there would be some more features that you can expect to come in the first half next year. Interestingly, we also did a SAN boot, automated non-disruptive SAN boot environment proof of concept recently for one of the bank. And so that also is one of the area we can start seeing more automation, scripts, etc., coming out of that work. This is the requirement. What aspects do I need to set up ahead? We need to make sure that a lot of stuff actually happens right when you add the system to the grid itself. When you add the system to the grid, then this pool gets linked, the port set gets linked. So grid understands if the migration is initiated, where does it need to go? We need to migrate. And then, like I mentioned before, the metadata migration, etc., we have already discussed. So that aspect happens once this add system to the grid has been done. It kind of knows where it needs to. The zoning is, at least as of 910, zoning has to be set up manually, and that's it. If those two things are there, then you are ready for the migration. So this is actually trying to show if you do have an environment which has got host automation, like the native OS support or Ansible, or we have also built some, some scripts on Linux, for example, which can hook on to the unit attention that get raised as a part of migration and do an automated rescans. So there is only one intervention point for committing the migration. If you don't have that environment, then the user need to do a rescan manually, so that the event gets raised. So there'll be intervention. Ability to roll back is an important thing. If you're not happy with the migration, you should always have an option to go back, fix the problem, and reattempt the migration again. So I'm going to run through some of these slides. So this is a partition migration slide, which is sort of, this is where from the grid dashboard that we saw, it give you a migration option. You can initiate the migration. We saw this, and these are the whole plan, and most of these steps are automated. Evolves, the migration is happening. It's going to show you this migration is in progress. It's going to pop up some of the errors, or if there is an action that is required, it's going to pop that up, and it's going to ask for the user intervention. If there are no errors, then we just hope that you have to only click the commit or the rollback based on what you see. You're happy with the your workload is happy, then you can just go ahead and commit that, and that's it. So this is how you would actually get to see what's happening from the dashboard in terms of the migration. How does it look? What's an estimated time to complete, etc., etc. So what's going on under the hood? This is where a lot of questions I'm getting last few months. Everybody wants to know that. So the migrate storage partition, the first intervention is initiate the storage partition migration. And a lot of these actions in terms of the dry run pre-check, set up the, if it's fiber channel, then fiber channel. If not, then Ethernet, whatever the setting up of the partnership, setting up of the replication policy, and assigning the replication policy to the partition. All of this happens in an automated way. Then the metadata replication happens. There's volumes with the same SCSI ID that gets created on either side. And the data replication sync gets into the progress, and the data sync completes, and the host side, based on the automation that they've hooked on, either native or Ansible or through the scripts that we are providing, it'll be able to do the rescan. It'll understand it to be an active sort of a thing, and this is the place where it's exactly matching like a PBHA, and that's why it will provide the high availability. This can also be exploited for the maintenance. If you want to take a system for the maintenance, we're going to talk about that use case. This is how it actually looks internally to the host. It's like the same UID that's going to be shown to the host, and so under the hood, it is like an HA technology only. Now we reach to this particular point when then the committing the storage partition migration, that's a question that get asked. And then at which point, once you've clicked that, the replication policy gets removed and the partition has gone away from the source. So that's that's how it works internally. And then there are some AI assists that are, that have been developed, and these AI assists, they allow you to, accelerate the decision making, and so you can initiate that partition placement, and then you can initiate that from the grid dashboard. Then it analyzes and gives you, based on the various aspects, right? The historical capacity, IOPS, data rate, latency, CPU utilization. It'll bring up the list of candidates, and then user can select one of them. Admin can select one of them, and then the normal, migration flow that I had discussed that ensues from here. So these are the key use cases I can think of. The new storage is added to the grid. How this is, I would say it's a differentiating technology using which, and optimizing IT, that, that is a key requirement, how we can achieve that. A new storage system gets added to the grid, then yes, you can check, you can evaluate, it can evaluate the storage tiers. The AI can give a view that which is the best place to put your critical application. Maybe you have bought the most performing storage, so maybe you should be able to migrate your most important applications there. Yes, and you can do that using the partition migration. The storage is decommissioned. You have an older system getting removed from the grid. You can identify workloads running on the retiring storage system, evaluate rebalance strategy, or I need storage based on AI insights. I have some available resource. Can I move it? Yes, I move all of them, and the old system can be decommissioned. I can have the workload is facing a performance issue. I identify that. I've got some systems in the grid that has some resources. I can move it over there, and then I can get rid of the bottleneck. I have adding new workload and rebalancing requirement. I do not have enough resources of any of the system. Rather than buying a new system just for this new workload, can I just move around? And then AI again can give you the insights, and then you can do the move around. You can create the available resources and rebalance and satisfy the requirement. And there you go. The new system, new workload requirement is satisfied. Finally, planned system upgrades can be done using the non-disruptive partition migration. And this way, the hardware upgrades, the software updates are done without impacting the workload. You have some spare capacity in your grid. You can just begin, get them into the migration, start the migration, but do not commit. This will ensure continuous availability during maintenance using migration. If the updates cause a problem to the system, no problem, the other system will continue to work. Once everything is done and the maintenance is complete, then you can roll back. Thanks a lot. And sorry it was fast, but I'm happy to connect with you. And if you have any question, I'm ready to take that. Sorry, I went 1 or 2 minutes overboard. Sorry about that.